Steven is going to the doctor because he has bone pain and he wants to know what is causing this.
I am very sorry, but you might have cancer. I am going to send a bone sample, but there is a high probability due to your family history.
Oh my god, and now what I'm gonna do? I have to simulate. Doctor, let me know the results.
The doctor gives his mate the bone samples for the analysis.
Okay, now I analyze it. When I have the result, I will give you.
What's wrong? You are rare.
Look at my telomeres, they are irregular.
Oh, it is because you are telomerase positive, isn't it?
Oh, no, I'm not telomerase positive.
Then how you are sick?
Because I have ALT.
ALT? What is ALT?
The alternative lengthening of telomeres, or ALT, is a mechanism of telomere growth. This growth is due to recombination of telomeres, although the exact pathways are still unknown. Specific mutational events influence ALT activation, as mutation in genes that suppress recombination or alterations in the regulation of telomere expression. Once engaged, ALT uses DNA repair proteins to maintain telomeres in the absence of telomerase. ALT cells are characterized by heterogeneous telomere length, the presence of telomeric DNA and sheltering proteins in proteolytic leukemia bodies, extrachromosomal telomeric DNA, both linear and circular, increased numbers of DNA damage response FOXy, and an increase of sister chromatin exchange frequency of
Oh
telomeres.
yes, I know what it is. I had a friend who had also ALT caused by a mutation in p53.
Seriously? Can you explain me a little about that? Because I haven't understood it really well.
Of course, p53 is a crucial protein whose role as guardian of the genome is regulation of the cell cycle, DNA repair, apoptosis, cellular metabolism, and senescence. The majority of sporadic cancer exhibit loss of p53 activity due to mutation or deletion of TP53, an alteration in its signaling pathway. Alteration or loss of function of p53 is a common event in many tumors regardless of the telomere maintenance mechanism used. p53 alteration is associated with activation of ALT in more than 95% of immortalized ALT cell lines. p53 mutation alter homologous recombination processes and could be permissive for ALT through a loss of recombination suppression. p53 mutation might allow cells to bypass checkpoint control and therefore to divide uncontrollably, causing tumors.
Thank you so much. Now I understand it a little better.
Here I have the test results. The sample is negative telomerase. Surely it's a case of ALT.
After carrying out the analysis of the sample, we have come to the conclusion that you have the Lengthening syndrome.
And what does that mean? What are the options?
It is a disease that increases the chance of developing cancer, so I think that the only solution is gene therapy.